Okay, so starting a double reverse four bar. So we're going to be doing that because it's a very common type of lift that's used to get a lot of verticality on your robot. It makes it really easy if the game requires you to do something at a very high level. So we're going to start with some file management just to do a review on that. So we have to create an assembly, which is where we're going to build everything inside of the robot. Now once the file assembly comes up, go to the top left and click File, click Save As, and you want to save it inside of your CAD folder or wherever your Vex kit of parts is. You want to save it nearby that, just so that it's easier to find things that you've built already. Oh, I forgot to name it. Just go back to Save As. When you click Save As, let's name this Teaching Double Reverse Forward Bar. Save it. Okay, now the name of the browser changed, so it's updated. So a double reverse four bar, I'll explain how exactly it works as we go through the build. But what we want to start with is we want to take, if you go to your kit of parts and go to motion, we want to start with or not motion, go to structure. We'll use a 5 bar, so 1 by 2 by 1 by 25. Let's open that. And we're going to put it into a vertical orientation. And the way that it's set up right now, you can see that inside of the C is on the right and the front face is on the left. So if you look at it from an angle, it's like that. You can build it either way, but I want to build it from the other way, so I'm just going to rotate it around the X twice, so that now it's facing the other way. So we'll set up one right there. And now we want to set up one more facing the other way next to it, so that we get that kind of two bars facing each other, and we'll be putting things inside of it. So let's set this first C channel to our backbone piece. So we'll right click it and we want to ground it. So click grounded. And now it can't move while the other one still can. So first, we're going to start with the axle guides because we'll be putting our gears on top of those axle guides. So it'll make it easier if we have the axle guides already there. So we're going to be working a lot on this face right here. So what we need to start with is right click it. We want to open it so that we can edit the sketch on the front to add the circles where we're going to be constraining the axle guides to. So we want to look at it. It's oriented this way in the assembly because we have those 4 holes up there. So it's oriented this way. So then let's edit the sketch. And we're going to start at the center of this 5 bar. So we have 1, 2, 3, which will be the center. So we'll zoom in on that, use project geometry, and we're going to have 1 there and 1 there, because this is 2 in from the edge and this is 2 in from the edge. So there'll be 1 12th tooth pinion here and 1 12th tooth pinion here. And then for the axle guides, we have to add another one just outside so that the axle guide can be connected. So then let's go to circle and tangent. And you can also re-watch these guides when you're actually trying to build it, because it'll make it easier. So that's for the pinions. So we'll come back to this later for the other gears. Let me start by showing you where the pinions go. So we want to place the axle guides, which will be under motion. They're called bearing flats in here. So we want to place 2 of those here. And don't place them on this side yet, we'll get there later. So we want to start by constraining one edge of it to there. And we want to put the other one just below it. And apply that. And now the second middle one is going to go one above. And this one is going to go down one. If I can grab the circle. And now these faces, we want them to go on the outside. So they'll be going here. And then click the face so we can put the other axle guide. Okay, now we have those 2 first axle guides in there. So the next part that we place in here is the metal pinions. So in motion, you have these 12-tooth pinion gears, except these are plastic. And since this is a lift, yes, it needs to be fast so you can go up and down fairly quickly, but we're going to be using a lot of high strength piece applications here. So we don't actually want to use this plastic one. We're going to want to use a 12-tooth metal pinion gear, which is this. These ones have metal, or not that one. This is a metal pinion gear. In reality, there's like a piece cut out here, and there's an insert into it, but here they have it as one piece, which is basically what it'll be like anyway. So we'll open those, and we want to place 2 of those. And now since you haven't used this part yet, we want to open it, and we're going to want to put a 2D sketch on this face so that we can put a circle in the center. So just like before, the same way, project the geometry and use the tangent circle. Oh, I forgot the third face. And use the tangent circle. And when we save this, it'll appear on both of these. So we're gonna constrain these to one goes to this circle and make sure it's undirected, and one's gonna go to this circle. And see, those will mesh together and they'll turn each other. So now the next gear that we have to add is a high strength 62. Actually need an 84 tooth gear and it's not in here. So we'll go to V5 products. And this is the gear that we want. So we'll scroll down to CAD files, preview the high strength 84 tooth gear. And that's what we want. So then download that. Wait for the step file to finish downloading. And we want to go to downloads and go to the first file and click open. Okay, so then it loads and it pops in. But when you place it, you can see that there's not actually an insert in it. Oh wait, you know what we could do? Okay, so let's open this, open the gear, and instead of placing an insert, let's project the geometry from this face because it should be the exact same, or the center of the circle will be the exact same. If we project geometry, we use 3 edges. Oh, we have to make sure we grab the outside edge. Either all of them are outside or all of them are inside, otherwise it'll be the wrong size. So all of these are outside edges, like that edge opposed to that edge. So we'll do a 3 tangent circle, and we'll do those 3, and we'll finish the sketch. This might actually be quicker than putting an insert into the gear. So now we have the circle, but there's something else that we have to do before continuing. So we're going to want to place another CAD file in. We're going to want to go back to your kit of parts, go to structure, oh, sometimes it switches your file types to all models, just switch it to all files. I think in the last project we didn't have a 7 bar in here, so I think we downloaded it. So if we go to downloads, or go to wherever you saved the 7 bar from the last, when we were building the X drive, the 1x2 by 1x35, I have a lot of things saved here. So since I already showed you how to download that, we go here, place the 7 bar, and place it about there. Now, we have to make a smaller sub-assembly before we continue. What we have to do is, what you do when you make a 4 bar is we're going to put this gear on top, and it's going to be as if we put a screw through there and a screw through there. So we're screwing this gear into the metal so that when the gear rotates, so does the arm. So we're going to constrain this outer hole. We'd put a screw through that, and then we'd put a nut on the other side, like that. And then on the other side, we can't really see it. You can see it's already trying to rotate. So if you look at it straight on, we want to constrain this circle with that axis. And now this is another important time when you have to make sure that your axes constraints are undirected, because we want this flat piece. We want the flat side to be touching this outer edge of the gear. So apply that. And now this all moves as one. Now we're going to want another one of these. So what you can do is you can look at it from the side, and like we did before, highlight it, Control C, Control V. So now we have 2 of them. So the first one, we want to, so these, they're going to go, one's going to go on the top and one's going to go on the bottom. So we need to rotate them. So if you use, on the top left it says free rotate. If you click the gear, it'll move the gear. But then when you press escape and try to move it, the bar will come with the gear. So click the gear, use free rotate, and it'll move on its own as if it wasn't constrained to anything. But then when you press escape and you try to move the gear, the metal gets attached and it moves with it. So now if we look at this straight on, these gears will have to come out a bit. This gear will go like this, and I'll show you this gear actually has to, let's line it up with our view a bit more, and then rotate it 180 degrees. And then press escape and grab the gear, and the bar will come with it. So this bar is on the inner side, and the bottom bar is on the outer side. So that's important. Make sure you remember that. I'll explain why in a minute after we constrain these gears. So if we look at it back from this side again, for now let's move this other bar out of the way. These gears have to mesh right, so we have to line it up. So now that's lined up, we know that the hole on the other side of this gear is what it's constrained to. So we want to find out what hole that is so we can draw the circles onto it. So it looks like from the top circle that's drawn, it looks like there's 1, 2 in between, and then it's the circle that we need. So we'll go back to this part, open it again. We don't need to start a new 2D sketch, we'll just use the old one. Edit sketch. Project geometry. There's 2 in between, and then it's the one that we need. So 2 in between, and then the one we need. And then since we need to constrain the axle guides, we have to put 2 holes in order to have 2 axes where the axle guide gets constrained to. And then we'll use the tangent circles again. And finish the sketch. And now if we go back, save reminder, make sure to save the assembly. Whenever you save the assembly, it'll save every single part inside of it, so you only need to save the assembly. So now, let's click the axle guide, and let's make 2 more of them by grabbing them in the browser and dragging them out. That makes a copy. And we'll constrain those to these 2 new things that we did. So a tip on axle guides, as you can see on these bottom ones, since these 12-tooth pinions are so small, they have to go 2 holes next to each other. So if you think about it, you could use one axle guide and have each of these go through a hole on the axle guide and put 1 screw through. But what happened to us last year is that since there's only 1 screw holding it in, what happens if it gets loose? It gets loose over time. And since there's 2 bodies rotating inside of it, the 1 screw isn't enough to hold it. So these will actually like slowly jiggle to the side. And I can send you guys a photo of this. Like there's a gash, like there's a hole all the way across there. Like instead of these square holes, it's like a rectangle hole from there over there. So that's why we put them on separate axle guides, so that 2 screws can hold each one. But now usually you want the axle to be spinning through the center of the axle guide. So we'll put these ones right there so that they can be spinning through the center. So let me recap that. When you put an axle guide, you usually want the axle to be going through the center of it. So there's a screw on either side of it holding it. and you don't want more than one axle going through one axle guide, even though there's multiple holes, because then there's not enough power or there's not enough force with the screw holding the axle guide in to actually make it do its job. So let's look at these from the angle, and we'll constrain the centers first. Or actually, before I constrain the axle guides on, let me constrain, I'll constrain the hole to the gear, make sure it's undirected. And now let's put the axle guide on. And same thing on this one. I don't think that's the right one. I'm going to pull it back just so I can see it. Oops. Make sure to grab that. Make sure on this axle guide that you grab the drawing of the circle on the metal and not the gear's axis, because that'll cause problems. So make sure you grab the circle on the drawing, then grab the face, and we'll grab the other side of the axle guide. And then click apply. Same thing on the bottom. So on this, grab the metal. Let's go to the other side so we can see that gear's hole. Grab the gear. And then right now it's in a weird position, but we'll fix that. So just click apply. And we can just take it, drag it over, and just drag it back. You just kind of have to manipulate it to make sure it's in the right spot so you can just keep seeing it. Then let's put the axle guide on. Oops, I didn't mean to hit cancel. Apply. Oops. Oh, I accidentally clicked that. I accidentally double clicked it. So it entered the part. You can just hit return and you'll come back. And as you can see, I can like grab the part through the metal. So it's actually kind of useful if you can find those quick things because it makes it easier. So now, if we look at it from the side, this should be constrained so that it rotates around that. And this should be constrained so that it rotates around that. Now we need to do the offset constraints. So these gears have to, they have to be in line, but this bottom gear has to have enough offset that this metal isn't scraping this gear right here. So the way that we can do that is pull this apart, constrain the inside face right here, and constrain this face right here, and then we'll just offset it to make sure it works. So 1/2 inch is a bit tight, so we can try 3/4 of an inch, and that looks fine. So apply that, and now for these pinion gears, you should click, I'll do it from the home view, this face of the gear, and this face of the pinion, and you want them to be flush, so you can do that. Then I would say pick the face of this gear again and do that gear, so that everything's constrained to this gear. And then do the face of this gear and the face of this gear, and you can see that pushes it. So now all the gears are perfectly lined up. And since this bottom one is constrained, only this bottom one is constrained to this, but they all still can't move side to side. And just make sure that they can still rotate. And now this may look funky at first, but I'll show you how it works. In a down position, it's like that, and then in an up position, this goes all the way down, and that goes all the way up. I'll show you how it works in a bit, once we can get some more of it done. So the next step is to take this other C channel, and we want to constrain it. You can constrain it by taking like 2 circles that are on both sides. You can constrain it like that. This is probably the easiest way, just pick 2 circles. And now since you've picked 2 circles, it just slides in and out like that. Now leave this loose for now. We'll fix it after we put the motor on. So now the next step is the motor, which we have to place in. We downloaded the motor earlier, so it should be wherever you saved the motor. Let's rotate it just to make it easier. So place it like that. There's multiple ways to do this. There's a lot of nuance in this type of lift. I'm just going to show one way. You can make changes on it based on what the year's game is like. I'm going to, since you can see where the wire goes in here, just to make it easier, I'm going to have the wire go out the bottom, because that means that it can get to the brain shorter, so there's less distance, which doesn't really do anything significant except for helps you with wire management, so it makes it look nicer. So this motor has to be connected so that its axle goes through one of these small pinion gears. It doesn't matter which one, but there's going to be another side to this, and they both have to be on the same pinion gear. So I'm going to have, so since this is another reason, whether you want it in this orientation or you want it in this orientation. So if it's like this, since the 2 screws go in there, you can't put it on the top pinion because the axle has to go where the screw is going. So you have to put if it's in this position, the motor has to be, its axle has to go through the bottom pinion. But if it's in this position, the motor has to go on the top pinion because the axle goes through there. Because if it was on the bottom pinion, the axle for this gear would have to be going through the screws. So I'll just put it like this then. So I think we have to draw one more hole on this. So we'll just reopen the part. Edit the sketch. And I think it's one more hole right here. So we'll just try it, see if it's the right hole. Oh no, I picked wrong. Or did I? No, I picked right. So this is the new hole that we just drew. So that one, let me move this back. the top axis of the motor goes into the new hole that we just drew. Put it undirected for now, apply. And let's pull it back a bit. The hole just below that one has to go into this axis. And now these plastic faces are what touch the metal. And now since this motor is connected right here, just how I put the axle guides over here, you have to have the axle guides on this metal too. Don't forget them. They just go on the other side of the, like back here. But for the motor, since you put it back there, that's the only one that you can't really fit on the backside hidden. So I would, well actually on a build like this, since there's so much space here, and you have to have the space for this bar, you could actually move the axle guide to the other side. But it's really just preference at that point. So add the other axle guide because that actually matters for our spacing. So if I grab the axle guide and since you need, just like how we did the axle guides for these pinions, the bottom hole has to go where the axle is going, which is right there. And then the second axle guide has to go, that second hole in the axle guide has to go on the first motor hole. And then that face goes against this face. So that pushed it all the way over, which is fine. Just click OK, and you can drag it back. So this is basically what one we call them pods look like. So this is one double reverse 4-bar pod. Of course, you'd have axles go through it, and you'd have spacers and collars in here just to make sure it fits right. But this is one pod.